in our earlier sessions, we discussed about VHDL. Then we were discussing also about Verilog. So that we have discussed, but some part of third unit, that means programming, that we have not completed. But we will complete it in the practical session. Okay, so that means in tomorrow's session, we will have some Verilog simulation. But in today's session, I will move forward and I'll start revision of fourth unit, that is a state machines. Okay, already we have taken lot more time discussing about this state machines, but still we will discuss once again about this topic, and then we will have revision about this. Okay, so what is mean by state machine? And what are the different types of state machines?
Ma'am, Melee and Moore are the two types of state machines.
Yes, Millet and Moore. These are the two types of state machines. Uh, Actually, state machine, that means a sequential circuit that has different states. Okay, and the diagram that describes about this state machine, different states, that is a state diagram. Okay, so we are going to discuss about these two types, that is a Moore and Millet type of state machines. Okay, so what is the difference between Moore and Millet machine? What is Moore machine? Moore machine in which output depends only upon the present state. That means whatever is the current state, output depends on that state. Okay, so we are giving the actually input. Okay, so this is the, here you can see this first block, that is a next state logic. So what will be the next state? That will be dependent on the present state and the inputs. Okay, and after, which will give the excitation to the state memory. That means it is actually a flip flop in that machine, and then current state will get decided. Okay, so output logic, so whatever is the output that we are getting, that depends on the this current state only. Okay, so that is called as a Moore machine. So if input changes, output does not change directly, it will not affect on the output, it will change the, depending on the current state, it will change the current state. Okay, and then output will depend on that state only. So here, when we are considering Moore machine, it will require more number of states, okay, as compared to Millet machine that we are going to discuss afterwards. So it will have more number of states, and but advantage of Moore machine is that it will require less hardware. Okay, so as compared to Millet machine, this requires less hardware because output depend only on the current state. Okay, it is not dependent on input, as the input is going to vary continuously. So it is not going to change the output state. So that is why the hardware required for this implementation, that is lesser. Okay, also this Moore machine that reacts faster to the input, and it gives a synchronous output and state generation. So as this is easy to design, so Moore machine that is easy to understand also. Okay, and that is easy to implement. So this is about the Moore machine. Okay, actually in your ISC there was one question about the test. Write a difference between Moore machine and Miller machine. Okay, so you have written that question, but I found when you are writing the program, most programs are copied. Okay, सगळ्यांनी म्हणजे मोस्टली नेटवरून कॉपी केलेले प्रोग्राम्स होते त्यातही आणि म्हणजे कम्प्लीट प्रोग्राम लिहिण्याचे बऱ्याच जणांनी कष्ट नाही घेतले. तुमच्या आयएससीचे पेपर चेक करताय ना मला म्हणजे बऱ्याच जणांचं असं लक्षात आलं की प्रोग्राम कम्प्लीट नाहीये, लास्टचे एंड केस किंवा एंड इफ स्टेटमेंट्स वगैरे हे तर नाहीच आहेत. मे बी काही जणांचा असा प्रॉब्लेम झाला असेल की अरे इमेजेस नाही घेतली कारण तेवढंच आहे पाठ, पण ते नाहीये. ओके, अँड दॅट मे रिड्यूस युअर मार्क्स. ओके, जेव्हा तुम्ही कॉपी ते प्रोग्राम लिहिता त्यावेळेस जर तुमचा कम्प्लीट प्रोग्राम नसेल तर तुमचे मार्क्स कमी होणार आहेत. त्यामुळे केअर घ्या की तुमचा प्रोग्राम हा कम्प्लीट असेल, नीट असेल, अँड डोंट कॉपी. जे तुम्हाला अंडरस्टँड झालंय त्याप्रमाणे प्रोग्राम लिहा. ओके, नेटवरचा प्रोग्राम तो लक्षात येतो कारण तो तुम्ही जस्ट कॉपीड असतो, त्याच्यामध्ये तुम्ही लक्षात घेऊन नाही गेलेला. ओके, so don't copy whenever once this type of questions are asked. Okay, so take care about that. ओके, आणखी काही जणांचं असं लक्षात आलं की त्यांच्या आन्सर शीट्स प्रॉपर फॉर्मॅट मध्ये नाहीये किंवा बऱ्याच जणांच्या ब्लर आहेत, त्या लक्षातही येत नाही. तेव्हा जेव्हा तुम्ही इमेजेस पीडीएफ सेंड करता तेव्हा प्रॉपर आले की नाही त्याची इमेज हे बघा आणि मग सेंड करा, अपलोड करा. ओके, कारण आत्ताच्या तुमच्या पेपर्समध्ये खूप जणांचे आहेत की ज्या खूप ब्लर आहेत इमेजेस, तर त्यामुळे मग ते बघायलाही अवघड जातं. सो टेक केअर अबाउट दॅट ऑल्सो. Okay, so this is a Moore machine and another type of machine that is a Miller. Okay, now the difference between this Miller machine and Moore machine is that in a Miller machine output depends on the current state as well as current input, okay, or present input. So whatever is the input that we have given at the instance, okay, that will also affect output state. So here you can see that the first block of this diagram, that is a next state logic. Okay? So that depends on the present input as well as current state. Okay? And then we will get the excitation from this next state logic. So what will be the next state? That will be decided with this logic. And then after that, this whatever excitation that we are getting, that will be given as an input to state memory. Okay, and that will decide, depending on the clock signal, that will decide a current state. Okay, so this current state and current input, so whatever is the input here, you can see that is again given as an input to output logic, and that will decide final output. Okay, so that means here you can see that at this block output depends on the current state as well as current input or present input. So if input changes, output also changes. Okay, so that means if logic level of the input is changing from 0 to 1, that will also affect the output also. So here in a Mealy machine, remember that output depends on the present state as well as present input. Okay? But in a Murray machine, output depends only on the current state. So here, as uh, output is dependent on the current state as well as current input. So less number of states that are required in the Mealy machine as compared to Moore machine. And also as this output is dependent on the two inputs, that is the one is the current state and another one that is the present input. So more hardware requirement is there for circuit implementation, and also it reacts slower to the input. So that is the one disadvantage of this circuit, this machine. Also it generates a asynchronous output. So as more hardware is required, so it is also difficult to design. So these are some of the disadvantage of Mealy machine, and that is the difference between the Mealy machine and Moore machine. Okay, so um, we are going to design now a different applications of these machines, okay, using these machines, okay, a Mueller machine or Murray machine. So the first application, that is a sequence detector. Now what is mean by sequence detector? What is mean by sequence detector?
It is a circuit which detects the sequence.
Yes, it is the circuit which detects a sequence of the input. Okay, so that means suppose we are having certain predefined series of input. So whether we are getting the same sequence at the output or not, that is detected, and depending on that particular uh, output signal, that will be high or low. Okay, so you can see here the block diagram of sequence detector as a one input, that will be a clock. So depending on the clock, it will check with what is the input. It may be a rising edge of the clock or falling edge of the clock. But depending on that clock signal, it will define, check what is the input at that state. Okay, and then X is the input. So it will check whether we are getting the predefined sequence of the inputs here, and then if we are getting that sequence, then output will be high. Okay, so here there is output signal that will be high if we are getting a predefined sequence, otherwise it will remain low. Okay, so we can have two types of models for this uh, sequential circuit. So where we want to detect this sequence, that is the one is the Mealy machine and another one that is a Moore machine. Okay. So as we know that Mealy machine, where the output depends on input as well as state of the system, while the machine, that is the machine where output depends only on the current state. Okay. So let us have one example for this sequence detector, that is we want to detect a sequence of 110. Okay. So what we want, at each of the rising edge of the clock, we are going to check what is the input, and if we are getting at each rising edge, if we are getting the sequence like 110, then output will be high. Okay, so here you can find that for the first clock signal, input is 0. Okay, so then at second clock signal rising edge, input is 1. For the third, it is also 1. And for fourth, it is 0. So that means here from second clock signal, we are getting the sequence 110. So at this clock signal, that means at fourth clock signal where the output is 0, as we are getting the predefined sequence, that is 110, we will get high output. So here you can see W is equal to 1 at this clock edge. Okay, so that is the circuit that we want to design. Okay, so now we want to draw a state diagram for this. So we have, we want to draw a state diagram for 110. So is it possible for you to draw this state diagram using Moore machine for 110? To draw a diagram, state diagram for a sequence detector of 110. Okay, you can take 5 minutes to draw. काढता येणार आहे का सगळ्यांना? काढायची आणि मला दाखवायचं आहे, म्हणजे तुमचा व्हिडिओ ऑन करा आणि तुम्ही ते डायग्राम दाखवा. While you are drawing this straight diagram, I'll take your attendance. Roll number 1. Roll number 1. 2.
Present, ma'am.
3.
Present.
4.
Present, ma'am.
5.
Present.
6. Roll number 6. 7.
Present.
8.
Present. Present.
9.
Yes, ma'am.
10.
Present.
11.
Present.
12. Roll number 12. शीतल. ओके, शीतलचा मोबाईल कुठे आहे चेक करा. 13.
Present, ma'am.
14.
Present, ma'am.
15.
Present.
16.
Present, ma'am.
17.
Present, ma'am.
18.
Present.
19. 19.
Present.
20.
Present.
21.
Yes, ma'am.
22.
Present.
23.
Present.
24.
Present.
25.
Yes, ma'am.
26.
Present.
27.
Present, ma'am.
28.
Present, ma'am.
29.
Present, ma'am.
30.
Present.
31.
Present.
32.
Present, ma'am.
33.
Present, ma'am.
34.
Present, ma'am.
35.
Present.
36.
Present, ma'am.
37. 37. 38. 38. Rishikesh.
Present.
39. 39.
Present.
40.
Present, sir, ma'am.
41. 42. 43. 44.
Present, madam.
45.
Yes, madam.
46.
Present.
47. 48. 48.
Present, ma'am.
49.
Present.
49. 50.
Present. Present, madam.
51.
Present, ma'am.
51. 52.
Present, ma'am.
Yes, madam.
53. 53. Rishikesh. 53. 54. 54. 55.
Present, ma'am.
56.
Present.
57.
Yes, madam.
57.
Yes, madam.
58.
Present.
59.
Present,
59.
madam.
60. 61. Okay.
59 and present, madam.
Okay. Avinash is there, na? 60. 61. 61. 62. 63.
Yes, ma'am.
64.
Yes, ma'am.
65. 60, 65. 66. 67.
Present, ma'am.
68.
Yes, ma'am.
69.
Yes, ma'am.
Ma'am,
Hmm.
19 roll number.
Okay. So have you have you completed your state diagram?
Yes, ma'am.
Okay. So Avinash, share your diagram. Sheetal. Prajakta,
Yes, ma'am.
please share your diagram.
मॅम माझ्या नावाला पिन केलं की दिसेल ना?
Oh, yes, yes. Pin to Prajakta so that you can see this diagram. So is it visible to all?
Yes.
So now explain this. So who's going to explain? Kaustubh. Now she has drawn the straight diagram. Explain this.
If S1 is equal to 1, then it change the state in S1 to S2. And
Hmm?
madam, थोडस वरती पकडायला सांगा की काही दोनच दिसतात S1 आणि S2 दिसतात फक्त पर थोडं वर ओके S0 there is the four states that is the S0 S1 S2 and S3 then the if S0 detect 0 then it in same state and if S0 is state S0 get 1 then it change the state from S0 to S1. Okay, if S1 get a 0 then it change the state from S1 to S0 and if it get S1 then S1 is change the state from S1 to S2. Okay. After that S2 get a 1 then it cannot change the state, it remains that state. And if we get S0 S2 is 0 then it changed the state from S2 to S3. Then if S3 is given 0 to then it change the state from S3 to S0 and if we get S3 uh, is equal to 1 then it change the state from S3 to S1.
Okay. And at that state, output will be equal to 1. Okay.
1.
So here you can see that in a circle you will find the state name and what will be the output. Okay. And at each of the arrow you will find what is the input. Okay. So depending on the input, output will get changed. So here, as this is a Moore machine, so number of states that are more. Okay, actually we want to detect a sequence of 110, but we require 4 states. So for to detect this sequence, so remember that whenever you are drawing a state diagram using Moore model, then there will be a one state more whenever you are designing a sequence detector. ओके म्हणजे 3 बिटचा सिक्वेन्स तुम्हाला जर डिटेक्ट करायचा असेल तर तुमच्या 4 स्टेट्स असतील ओके सो हियर यू विल फाइंड अ 4 स्टेट दॅट इज S0 to S3 and then depending on whatever is the input that is detected in that each of the state you will get you will move towards the next state or it may be remaining in that state only or it may return to the previous ओके म्हणजे ज्याप्रमाणे तुमचा सिक्वेन्स असेल त्याप्रमाणे तुमचं इनपुट असणार आहे त्याप्रमाणे तुमचं स्टेट चेंज होणार आहे ओके सो इथे as the sequence was 110 so initially when in this machine is in the initial state that is output is 0 so if input is detected as 0 then it will remain in the same state. If it is detected as 1, then it will move to the next state that is S1. Okay. Now in S1 state, if 0 is detected, then it will again return to the initial state. Okay. But if 1 is detected, then it will move to the S2 state. Okay. That means now, till now, we get a sequence of 1, 1. Okay. So if in the S2 state, suppose 1 is detected then it will remain in the same state कारण previous आपल्याला 1 1 चा sequence मिळाला आता जर 1 मिळाला तर ते त्याच स्टेट मध्ये राहील पण जर 0 मिळाला तर 110 हा sequence complete होणार आहे त्यामुळे तो नेक्स्ट स्टेटला मूव्ह होईल दॅट मीन्स S3 ला आणि आतापर्यंतच्या सगळ्या स्टेट मध्ये आपलं आउटपुट सिक्वेन्स कंप्लीट झाला नव्हता त्यामुळे आउटपुट हे 0 राहणार नाउ इन दिस स्टेट as the sequence gets completed that is a 110 so output will become 1 okay now in this state if 1 is detected then it will return to the state that is S1 okay and if it is 0 detected then it will return to the initial state that is S0 okay so this is the sequence detector for 110 ओके तो सगळ्यांना हे क्लिअर झालं स्टेट डायग्राम काढता येईल कुठल्याही सिक्वेन्स साठी युजिंग मूर मशीन कुणाला काही डाऊट आहे का याबद्दल Those who are having any doubt regarding this, they may ask. So now if you pin to my presentation, so there you will find a VHDL implementation for this sequence detector. Okay, so this is the VHDL code for sequence detector 110. So now I will give you one another sequence to draw this state diagram. So draw sequence detect state machine diagram using Moore machine for the sequence of 010. Okay, so this is a one more work or exercise for you to draw a sequence detector state machine diagram for sequence 010. Okay, so complete this exercise and send it to me. Okay, you can consider this as your homework. Also write a VHDL code for this sequence detector. That is, you want to detect a sequence of 010. Okay, so this is your homework for today.